Hello, Math 2 students. Today I hope you're ready to learn how to find the zeros of the function. And we're working with the quadratic function family. So our function is f of x equals minus 3x squared plus 75. And we want to find the zeros. Well, one of the things about the quadratic function family that seems a little confusing at first is that in the textbook and teachers, we use the word zeros, solutions, roots, and x-intercepts. And for the most part, those mean the same thing. So sometimes students think we're asking 4 different questions when we're really looking for just about the same information whenever we're asking for any of these 4 things. So the first thing that maybe pops into your mind is, if the zeros are the same thing as the x-intercepts, why don't we just take our function and make a table and graph it, and then wherever the line crosses the x-axis, we'll know what the x-intercepts are. And if we know what the x-intercepts are, then we're going to know what the zeros are. So to start out, if we were going to make a table, this is what our table would look like. Our table, we would need to go 2 to the left and up 63. 2 to the left and up 63. Our graph paper is definitely not big enough. 1 to the left and up 72. 1 to the left and up, our graph paper is not big enough. This is not going to work. We should have known that when we looked at our original function, because we know that this 75, if our C value is 75, it's going to translate our graph up 75 units. And if our A value is -3, our graph is going to open down, and our graph is going to have a vertical stretch of 3. So it would be way up here, 75 units up, opening down with a vertical stretch of 3, and somewhere it would cross the x-axis and it would have an x-intercept. But maybe the graphing method isn't the best way to do this problem, because we need an enormous piece of graph paper. So another thing to think about, we've already found the solutions or the roots. So when we found the solutions or roots, we didn't have a problem that looked like this. We had a problem that was 0 equals -3x squared plus 75. And we learned how to solve that equation, which is in standard form, by factoring. Well, what do these two things have to do with each other? This is a very important concept to wrap your head around right now. So how is this equation related to this graph? Well, it has to do with all of these points that I put on the x-axis on the graph. If we're looking for the x-intercept, we know that we're going to have a line that crosses through somewhere on the x-axis. And every single one of these points on the x-axis, and even the ones that would be in between these points that I didn't label, all of these points have a y that is equal to 0. So this is function notation. Here's what the equation would look like if it wasn't written in function notation. And we know that if we're looking for the x-intercepts, then our y value is going to be 0. So we really want to know, what is our x value when our y value is 0? And now this looks exactly like one of the equations from the last chapter, where we would solve to find the solutions or the roots by factoring. So since graphing looks like it's not going to be a very good way to do the problem because the numbers are so big, maybe it would be more practical just to solve this equation by factoring. Then we'll know what x is when y equals 0, and we'll know what the x-intercepts or the roots or the solutions or the zeros are, and we won't need an enormous piece of graph paper. So the first thing we need to do if we're going to solve this equation is we need to take out the greatest common factor. So our a value is negative, our c value is 75. I know that 3 goes into itself once and 3 goes into 75 25 times. So now my equation is going to look like this. So I'll have negative 3 times x squared is negative 3x squared. And negative 3 times negative 25 gives me positive 75. Now that I've taken out the greatest common factor, my remaining polynomial is a binomial, and there's a subtraction sign in between. X squared is a perfect square because it's x times x. 25 is a perfect square because it's 5 times 5. So I know that my binomials are going to make a sum and difference pattern because this is the difference of two squares. So I'm going to have 0 equals negative 3, and it's going to be a sum and difference pattern. X times x is x squared. 5 times 5 is 25. And now I just need to find my zeros by solving using the zero product property. And so in front I have a greatest common factor, but there's no x there. So I'm not going to have 0 as one of my zeros. Here, this does not have anything but an unwritten 1 for its coefficient. So we can use the opposite. So x equals negative 5. And here we have no coefficient in front. So we can use the opposite. So it's x equals positive 5. So negative 5 and 5 are the zeros of our function. Those are the x values when y equals 0. So even though we weren't able to make our graph because we don't have a big enough piece of graph paper, I do know something about my graph. If these are the zeros, if these are the x values when y is 0, I know that my graph is going to go through that point right there, and my graph is going to go through that point right there. Because those are the points on the graph where x equals 5 or negative 5 and y equals 0. So we just found the zeros by finding the solution to this equation. These are also called the roots. These are also the x-intercepts on the graph.